Okay, let's get started. So, what we have is so we were, where did we leave it yesterday? We left it at, oops, up to attach that folder, connect to server. Okay, there we go. Gotta be a way to do that automatically when I log in. Okay, so where did we leave it yesterday? We left it with, we have a metadata service that is going to store metadata, right? So conceptually, this is what I want in the metadata. So if I do, got my metadata table, and then I add locator records to that metadata table. So my tables look like, here's the metadata table, and it has an ID, a date, time, location, runtime, and tags. And we have a locator table, which currently just has the source and the path, and then a reference back to the metadata table. So this means we have a one-to-many mapping between the metadata table and a locator, which is fine because the idea being that it could be the same thing but pointed to at different files, right? So when I join the two tables, oh wow, I'm really not ready this morning. Okay. So when I join the two tables, I get the metadata and the location of a given file. Okay, great. Go ahead and close this, and we can go back to the metadata service. So how would we find the metadata? We'd find metadata by tags, by location. Let's start with tags. So let's start with, well, we know that, for like file service, the file server is an interface so that we can mock it out when we're testing. Oh, this will help with a graphical image of what I'm talking about when I talk about the layer cake. Okay. So here's what I mean when I talk about the layer cake. So the database tables are at this layer, right? This is the service that's going to manage the data on disk. Then we've got the code that I write that specifically connects my data access layer, the part that I write, to the database layer. That is good coffee. The database layer is, again, mostly prescribed code that will execute selects and iterate through results, etc., etc. You could use an ORM. ORMs are kind of a mixed bag for me. I think sometimes it's not that they're inherently bad, but they get misused. So, for example, I've seen cases where people pull back large result sets just to count the number of items, or they've got these tables which are very large fields, usually lots of text or small binaries or whatever in them, and they haul back all this data just to get a very small subset of data, and they really should be going into the ORM and saying, okay, I need a count method, or maybe they're not doing what they need to do in the ORM to properly do counting, or they're not uh, writing their own queries to do selects over some of the information, or they're not marking fields as lazily initialized, so they're only pulled back when you actually go into that and request that field. But the point is, it results in a lot of memory bloat and slow performance, not because the ORM is necessarily bad, but because people don't use it effectively. And so I find that sometimes it's just easier for me just to go straight to the database where I'm really quite comfortable. Okay, so that's my data access layer, which is going in and grabbing data from the database. Then I've got my logic layer, right? This is the stuff that I want to get to from yesterday, where I talked about having an image as kind of a model in the system or a concept in the system. That's up here. And then at some point I need to interface with the service interface, right? So I have a web request in, and I need to translate the contents of the HTTP request to something that I can go ahead and execute methods on my logic layer. Like, for example, searching for images by their tag. So in my service layer, I need to translate the parameters in the HTTP request and validate all that and so forth to be able to execute a method in my logic layer to find all the images with given tags, for example, which then will turn around and call into my data access layer to execute my this metadata service that I'm currently writing. And then I'll hit the database. And finally, at the top of the stack, I've got my kind of service interface. And this is stuff that's built for me. So at the top of the stack and at the bottom of the stack, the stuff is built for me, and the only thing I'm doing really is configuring it. At these two layers, the server interface layer and the data access layer, I'm basically writing code that's almost formulaic in the sense that I'm having to process a given set of inputs and outputs in a relatively predictable way. And then logic layer, I'm kind of this is if this is just a little bit of configuration, say this is 1 to 5% code, and this is 1 to 5% code. This is maybe 15% code that I write, and this is 90% code that I write, right? So that is the way I kind of view things. And so right now I'm still operating at this layer. All right, so let's talk about the metadata server. So we probably have a find by tags method, and even if we have like like what we did yesterday with a query type query parameters object, where we have maybe tags maybe we've got tags that are a string, and we have find, which takes a query parameters and returns a metadata slice and an error. We probably at some point would probably have a convenience function like find by tags. This way, whoops. This way we get rid of repetitive code, which is to set up a query parameter object with just some tags and then executing find. So we probably would have that convenience method anyway. And to avoid having to do all the work of picking apart the query parameters and generating an SQL and so forth, I'm just going to go ahead and start with find by tags. And tags are just going to be a slice of strings. Oops. And it's going to return back metadata. And it's going to return back an error. Okay. So just to keep it, so what did I do here? Here I did my actual implementation was hidden, conceptually hidden. And in order to deal with the database, by the way, I put in an intercept, which allowed me to pass in this custom interface to be able to test database calls. But let's go ahead and talk about what let's get rid of this, since that was just thinking about it yesterday. Actually, let's go ahead and keep it. All right. Actually, that is pretty much what I want to do. So let's go ahead and create a function, new metadata server, and that gets a DB caller, and returns back a metadata server interface. So we can't return back an interface, so we need to return back something concrete. So we will call this, I don't know. We're probably not going to have too many other implementations of this than the database, but let's go ahead and call this DB, DB metadata server. So it is an actual struct, and we're going to have, what did I decide to do in file service? I want to keep it in line with what I did. Yeah, I called it. Yeah, no one needs to know. No one needs to have access to that. Yep. And I return Why are you angry with me? So I need to implement func. I need to implement the find by tags. There. Return nil, nil. Okay. All right, so new metadata server will return back an object, a reference to an object that meets this interface, and it is this metadata server underneath the covers DB metadata metadata server under the covers. Okay. So I don't like to go too long before writing a test. It makes me feel weird. Ooh, I got a typo. Metadata. Data. Okay. And let's go ahead and create a DB caller. Okay, let's go ahead and pass that in. And we can just quickly check if ms not equal nil. And if ms is nil, game over. Can't really test anything else, so we'll fatal out of that. Returned. And then we can check to make sure that if DC some. Okay, we can do cast, so we can do some caller, okay, equals we can do some server, okay, equals DB metadata server forget what the casting is. It's not quite it, right? That's it. If it's not okay, again, game over. Cast server to DB metadata server. Okay, else. So at this point we're okay. So if some server dot DB not equal to TDC, this should probably be a reference, right? If we're going to do the equality thing like that. Expected server caller to be the test caller. Okay. So let's go ahead and run that. Okay, so we know our trivial function works here, right? So let's go ahead and start writing the test for find by tags. All right, so let's what else? Oh, the joy of streaming when I'm at home. Um, so anyway, I'm going to just, can I mute the stream here? I wonder if I can mute the stream. So let's go ahead and see if there's a mute button on this thing. Nope, not really. Well, I'm going to go ahead and call it a day then. Okay, let's restart. So we've got caller, server, and context is, so I've got this little useful method. Let's go take a look at that method and see if I can still use it. There it is. Okay, what does it do? It creates a new mocking interface, a new file service. Okay, that's why it's file server specific. So maybe we can split out this piece so it's reusable. So let's go ahead and create a simple test. That's kind of my package. Create test db caller, and this returns back a test db caller. And did I want to return back? Oh, let's return back the context. Make life easy. Okay. Okay, so return because we need to reach in there to set up the mock returns, right? So we're going to return back a test DB caller, and we're going to return back a context background. Okay, so we can go to file service, and we can replace that part with mockdb x. What do we call this? Create. There. Right. Okay, so that's good. So we can okay, so we got a caller and a context. So if the caller, so the query we're going to write is basically going to be a join across the metadata table and the locator table. So we're going to query across that where we have a match on the tags. So let's So we're going to expect query, select. Let's leave that as select for now. We'll return rows. Okay, so what are we going to be returning? We're going to be returning, what do we want to be returning? So we'll return rows. It takes a slice of strings which represent the rows. Oh. So new rows. Okay, and the new rows are going to be returning back a slice of strings, which are the columns. So let's do this as ID. That's our metadata ID, right? That is the primary key of the parent column. Then we've got date captured, time captured, location, runtime, tags, path, source, path, right? So we don't return the ID of the locator because it's not really useful. And we don't return the metadata ID because that is the ID of the parent column. Okay. So now we're going to add some values. And what does add row take? Oh, okay. Now we're going to add some values. And we're going to do a 1. Now I've found out you have to cast these if they're not integers because it will assume it's an integer. And we're going to do time dot time dot date 2021 month 03 20 nanoseconds and location. Nanoseconds 0 location. Can I just do nil for that? Or is there time dot location? Okay. Okay, time dot date. So that's the problem, right? There's no separate time and date in Go, right? So it's a time dot time or a time dot duration, but it spans multiple two different concepts, right? And hour 13, 24, 6, 0, Okay. All right, so that's date captured, time captured. You know, maybe that is a bad. The reason I'd split it up was because I thought it would be possible to have some systems that only capture on a given date. But I don't think I'll ever query by time. So I think I want to revisit my notion of this metadata table. So let's go ahead and modify this. Let's make this a time stamp. Leave it as date captured. Get rid of this. Oops. Didn't do it. Oh, there it did. Okay. Let's refresh that. Okay. So we aren't going to have time captured. We'll just have that one date. Separate it. Okay, there we go. So we'll have the one date. We'll have the location, and we'll just say home for that. Runtime is nil. At least I think that's how nulls are done. Actually, it's a duration. So I don't know that we get a nil duration, but we get maybe time dot duration. Time dot seconds. Time is 0. A 0 length duration. Okay. For tags, I think we get a string of foo Now, be forewarned, I actually don't know how PGX is going to return arrays. And for tags, so that was tags, so source, we've got file, because that's what I think we want to do. We want to indicate that it is a file that we're dealing with and not something else. And we got a path, foo bar baz, right? Okay, let's add another row. So we're going to add this is actually let's make the same metadata record, and we're going to do the same everything except we've got another okay. So that simulates the thing that I was talking about where we could have multiple locators for a given piece of metadata. And let's do another one just to have another. Let's do 64.2 and make it a slightly different one. O2, and let's make this 09. So it's got a different time. Location, let's make it a different location work. Run time is again time that second 0. Tags in this case will be foo, bar, baz, and source will be file, and path will be foo, bar, quux. Okay, so that all right, so that is my expected result. That is a little messy. What is it not liking? Oh, one too many parameters. Okay. So new metadata server, and I'm going to pass in my caller, find by tags, and my tags are going to be foo and bar. So I will find by tags, and the result is metadata error. All right, I'm going to go ahead and stop the